Alright, in this video we are going to be talking about trapezoids or trapeziums, in Britain I believe. Anyways, here is some terminology, or first I should define what a trapezoid actually is. The only requirement for a trapezoid is that it has at least one set of parallel lines. So in this trapezoid that I drew up here, these two would be the parallel lines. And so note that in our definition, technically, rectangles and squares and such, parallelograms, these are all trapezoids. Of course, there are different definitions for this. Some people say that trapezoids are figures with exactly one set of parallel lines, in which case, this is the traditional way that we see trapezoids. But I would like to add that the trapezoid formula works for these figures as well. The trapezoid formula, the trapezoid area formula, trapezoid area formula is this. B1, or base, so the two parallel lines are called the trapezoid's bases. B1 plus B2 divided by 2 times h, where h is the height. This is also equal to m times h. So m over here, this line that I drew through the middle of the trapezoid, is called the midline, I believe. Mid-segment, sorry. Yeah, midline seemed a little simplistic. Mid-segment. This is called the mid-segment of the trapezoid. And the mid-segment of the trapezoid, the length of it, well, first of all, it's parallel to the two bases. So I can actually add this notch here again. The mid-segment is parallel to base 1 and base 2. And it is also its length is equal to the average of these two bases. So the formula for mid-segment is B1 plus B2 divided by 2. So if they ever ask, oh, what's the mid-segment of a trapezoid? It is equal to the average of these two. And I would also like to add that for a triangle like this, a triangle can also have a mid-segment, and its mid-segment is equal to the length of this here, length of its base, it only has one of course, length of its base divided by 2. And I would encourage you guys to think further on why these things are true. I think this is about it that you guys actually are expected to know about trapezoids in competitions. Just remember this formula, or these two. Remember what a mid-segment is. And I would encourage you guys to actually split up this trapezoid and figure out why this kind of formula works. And whether or not it works for, weird looking trapezoids. Like, here's a right trapezoid. I think, I believe this is also a trapezoid, an obtuse trapezoid. And we can also have an acute trapezoid. Although this is kind of looking like a parallelogram. These are kind of my bad drawings of trapezoids. And, as a kid, one way that I justify this formula to myself was that I broke this kind of trapezoid in half. And I said, okay, so I can take this trapezoid over here, and I can take this part here, take off the one half of it, and so this is B1, and then I can add on B2 on the bottom, and so I can kind of flip this over and attach it on the other side. So I would have this, I would have this, B2, and then the height of this would be 1/2 h, which means h over 2. And so this is just a parallelogram, of course, and so it makes sense why we could use this formula to get the area. Of course, this kind of thinking doesn't work all of the time. It doesn't apply for many of the weird kinds of trapezoids, right? Like those. But I think this is, generally a good start for getting an intuitive feel for the area formula of a trapezoid. Anyways, thank you guys for watching, and tune in for the next video about parallelograms.